No, for the Win32 API, the first thing with obviously Invokes is just how you call the function from an external DLL. That's not part of C#. So I made a class here called Win32, and in it, just doing Invoke. So it needs to be static. Then you need the word extern, the return type, and I actually found a function here that I'm going to use as an example. Get cursor pos, so I can bool get cursor pos. So the only argument it takes is out this struct LP point, and it's called LP point. So out P point. Now, obviously LP point doesn't exist for this, but we're going to add it. Also need to mark it with DllImport. Then you are going to need to use a using for this. And then we're going to put in quotes here the string, which is the DLL you got it from. You're on here is at the bottom in this one. Most of them are user32, but if you find something else, then you can do a different thing, obviously. User32. Then there are a few options here. One we're only going to use is set error. I'll show you what this means in a little bit. And also, since we're using the bool, this is a bool specific thing. We're going to put return, put Marshall as on manage type dot bool. Now this is because C++ doesn't actually have actual bool type. It is just a number that is just like kind of disguised as a bool. And because of this, we're not going to get correct results if we don't use this Marshall as. But if this was just like an int or something, you don't need this. Now, for this here, now, technically in this example, just using the system.drawing.point should actually work, but for the sake of a lot of stuff not being like that, I can struct for this. So let's not make it here. Make a LP point struct. We can actually just call this a point. So you don't need the LP, that's like a prefix, basically. Call it a point, and we're going to use another attribute, struct layout. Now, our layout type, layout kind, sorry, dot. So right now we're going to be using sequential for this. Sequential basically means that when the memory is marshaled to this, or from it, it is going to be put in order, which I'm pretty sure is the default. Yes, it is. But it's nice to just have this here if you're going to be using it in external functions. So now you can see, you can use this, see what is the point structure. So you can open that here, and I have it open. You can see the number. So long X, long Y. So now you might assume this means we can just put long X, long Y, but that's actually wrong. This long is 64-bit, as you can see here, as you probably know. However, the weird thing is, because of Windows and stuff, if we go to this data type, Windows data types thing, we can actually see what each of these types are defined as. If we go to long, we can see it's defined as a long, but then if we look here, 32-bit signed, you can see that's the range. And this is the range of an int. A 32 signed integer in C# is actually int. So it's kind of a prank. So this is X and Y. Then if we want to make this public, we can do something like this. Just make a constructor. These are just like methods, so these don't affect these won't affect our struct at all. So we're good just adding these here. It's fields you have to worry about. Like if I added this, since this actually makes a hidden field, or even this, which is directly a field, you can't do that. You can't be adding those. So we can make a constructor though. x equals x. That's the line. So now we can just use this like a normal struct. This is actually equivalent to the system of drawing struct. These are the same thing. But for the example here, this is a simple struct that we can easily make. Example. So it's recommended you should have these private. I think for like security or something. Not exactly sure, but you're supposed to. Convention is to have these private, and then you would have a public. That's just basically a wrapper for this. So get cursor puz out, and since these are the same, we can. So I might skip the cursor puz. The other way, easier way I want to kind of do this is make this return a point, and then no arguments. This also allows us to have both. So we can just have this return this 132 point. So what we would do for this is just get cursor puz now out point, define point, and then true. So if this succeeds, this will return true. So then we could just return that point. If it returns false, we can just return the default point, which would just be an empty point. So we have this. So let's see if we can make structs here. And the next thing we're going to look at is if a different function, there's actually another function that uses inputs. And here's the struct for it. So let's see, we have the word type. We can just go into our data types. Look, the word, which stands for double word, which bunch of kind of junk here. Where is it? Oh, this is pointers. Here it is. The word 32-bit unsigned integer. So 32-bit unsigned should tell you that's a uint. So I want to have a struct for this. Public struct input. You have uint type, which signals if this is a keyboard, mouse, or I forgot the other one. What is it called? Or a hardware input. So you might notice here union. What does this mean? Well, C# union, or sorry, a C++ union basically means any of these can have a value, but they occupy the same amount of space. So your first thought might just be, oh, can I just type union? No, it doesn't light up. And then you might just look it up, and if you look it up, you'll see there are no such things as unions in C#, because most of the time you wouldn't really need it. But when we need this, we need it. So the way we can actually do this is by using another struct layout type called explicit. I don't know if this explicit is supposed to be for anything else. I've only ever used it for unions, but I don't know. I think it maybe has another use. So basically what we can do in front of the fields is we can do something called field offset. So this is basically the amount of bytes from the start where this is. So at 0 would be the start of the struct. So this type is at the start of the struct. Now, how do we know what to make the next one? Well, the next one, since this is 32-bit, that means that is 8 bytes. Sorry, not 8. That is 4 bytes, because converting from bits to bytes is dividing by 8. So, and the field offset takes bytes, so we want field offset 4, aka field offset 32 bits, to be our mouse input here. So I don't have a mouse input struct at the ready, and I don't really want to make one. So if it's not important, you can actually use in pointers. If I know I'm not going to be using this mouse input, I can just put an in pointer here. It should be fine. Now, if you want to make these a union, we can actually do keyboard input and hardware input. Now, what this means is these all take the same amount of memory, which means if we read them, they're all going to be the same, which is what a union is. They all occupy the same amount of memory. So as long as they're the same type, they'll return the same thing. However, If it's different types, then you can run into some issues, so just keep in mind that that is a thing. So, what we can do, put a struct. Now, for the sake of this, I don't have these types at the ready, so I'm just going to make mouse input, and I'm just going to make some blank structs here. Now, so, change this to input, because I don't know, let's say we're going to read this later, and we want to know each of these just in case. So, public input, we're going to be using them, want to set them, so then we're going to use the structs, or we're going to put. So, one way to do it, you want to type mouse input mi. Now I'm going to set mi type, and then notice it's not going to make me set these because this memory is already being used here for the field offset. So we only have to set one at a time. So then we can make like a second one like this, where this hardware input. So you get the idea. And then we did the same thing for keyboard. Now for this specifically, actually, this type actually tells us whether it's using the mouse input, keyboard input, or the hardware input, because, like I said, these are all going to be the same, read the same in the same block of memory. So, look here. See the type of the input for this can be one of the long values. So, this is what the constant is called in C++. We don't actually have these constants in C#. So, just read this, and if you want to name it, you could do that. Put, I don't know, in our Win32 class, you could put public const uint, what is it, mouse type, input mouse equals 0. So, and then, so we know we're doing that mouse input. If we put this in, we could say type equals 0, or if you, for whatever reason you really want these, I usually just use numbers, but if you're going to be using this a lot, I want it to be clear. Good. And then there, it's basically have the constant, though, plus constant here, basically the same thing. So we're going to say that this is definitely a mouse constant, or a mouse input, and then we can set mi to this. Now we can do the same thing. For keyboard, this should be 1. We're going to call these ki to make it a keyboard. So, and then you can imagine you do the exact same thing for hardware input. So let's use this point in our program. Console. We're going to do console.write to.get cursor. So get cursor pos. This is going to be no argument to get this. Now, one other thing I would do, point override toString. This is basically when, so this is just going to call toString. Putting this and this are the same because right line is just going to call toString. So let's do toString solid. Right now, it's just going to return like whatever using Win32.point or whatever. That's not what we want. Want is for it to return X and Y. So we could do like, I think usually the way it's like this. Or you could also do like, want it like point notation, you could do like this. But I'm just going to put it like this because I want it like that better. That's usually how those work. So then this, you can see my screen's about 1920 by 1080, so this should be about like 1800 something X. And there, yep, see that makes sense because this is 1920 right here. So makes sense, this is 1800. Now this, keep in mind this is screen coordinates, so if you're trying to use this from some kind of window or something, this isn't the same thing, so. Yeah, so this is screen coordinates. You can see, that makes sense there. And so, next thing, we got structs, we got the union, we got p invokes. Now the last thing is the messaging loop. Now this is something weird. So, it's a loop, right? Now the problem with the loop is it obviously continues running and it's not going to allow you to run anything else while there's a loop running. So what we're going to do is we're going to use a while, but of course, like I said, our main issue is if there's a while running, it's not going to let anything else run, which, I mean, if we're using a message loop, blocking the whole thing to run the message, that doesn't make any sense. Why would you do that? Doesn't make sense. So what we're going to do is we're going to have like this start loop class start. So this is basically, we're going to be using basically the same code I used for my hotkey video. This is basically the same concept here. Wow, true. Then to add our Windows and messages. Message functions. And the one I want is called getMessage. Let's see, turns a bool. It's the same thing. So we could keep it here, or we could just put it in, and then we don't need a wrapper, and we could just use this privately. So, yeah, web services, don't forget that. So we're going to use this. Was that while true? And so, what are the things for this? A returns a bool, so we can keep that. Since it returns a bool, we also need this. Don't forget. Otherwise, it'll return, but it won't return like the correct value. It'll kind of be weird. So get message out, get message. Now, like I said, if you can place structs with these, if you don't need it, now I'm actually going to make a struct for this because this is important, obviously. Now, HWNT is in optional. So, this for now. I always use an in pointer for handles. This is a window handle, and I always use an in pointer for that because there's no reason you need to make the actual type. You can just use in pointer for this. It's more for like these messages. Basically, everything except handles should be using an in pointer for. You can see actually has a description. Yeah, I used to represent a pointer, which is the structs, which is why you should use actual structs, or a handle. So if it's a handle, just use them. You don't need to be going into the other stuff. So uint wmessage filter max. And I'm pretty sure this actually is a uint, but if I didn't know that, type uint. What actually is this? Go to uint. Okay. Do unsigned int. Now we could either use this, figure it out. So you can check int 32-bit, so it's fit. But the other way you can do it is 0 through, the max is 4294, so what's int.max? It's 214, but what is uint.max? You can see it's 42. So then if we did like sketch against that, you can see that, that's definitely not the same thing. So this is actually a uint. Actually lines up, so this is our message man. Your parameters are just for like C# basically, so it doesn't actually matter what you call them, but you should keep them pretty much the same thing. Now these are just filters, so these don't matter, so I'm not going to use this. Use those. Now, here's another thing. So, if we look at our getMessage function, we can see it says optional. This is optional. Then we can just pass null. No, because actually, yes, but it'll have to be casted because you can see null isn't actually a pointer. Now the way you're gonna have to pass this, basically the null for it in C# is actually, or in C++, sorry. When they use the null for it, they use this, which really is just basically null equals 0. So if we passed 0, now the two ways of this, either cast it, why can't I spell? Don't know what to do, okay. Cast like this, or the cleaner way to write it, which I like to write it, is just endpointer.0. Now this is the same thing, this is just grabs you a new 0 endpointer, and this is the same thing as passing. Basically leaving it blank in C# or passing null. What we're doing here is just passing null and telling it we don't have a window handle that we're trying to use here. So message min, and you can see you spell 0 as it's basically a filter, but go here, it actually says, I think in the remarks. Okay, yeah, here. If these are both 0, there's all available message, so no filter. That's what we want. So, do this, and what we're actually going to need is the struct, like I said. So, we want to read from the struct. Let's do message. Message, this struct is going to see if we it's here. This structure here, this is a lot, so in pointer HWND. UN message. WPARAM. Now this is another thing that we're going to look, like I said, in our types. Let's see what this is. So actually know what this is, but if you don't, you param. Oh, it's not a struct at all. This is just a data type. See here, message, and it says UN pointer. What is a pointer? To know. Pointer to it. UN. Oh, that's not the right thing. Here it is. Unsigned in pointer. That doesn't help. And you can see that this just goes back to an int pointer. Now, int pointer, what is that? Oh, wait. Pointer. So int pointer WPARAM. Pointer LPARAM. Now, this one's actually 64-bit. This LPARAM is, but they're both going back to int pointers. The other one's just 64-bit, so keep that in mind when you're going to be doing what we're doing in a minute. Now, dword, remember what the dword is, that is an int time. Now, point, like I said, we could either use point, or we can just use our point that we made. But he's here, that is our point that we made earlier. Now, also have Invoke. Double check that. Dword. Okay. 30-bit unsigned. Oh, that line. Now, we might need to access, we're going to make some methods for, such as we're also going to want to access the W and the program. You can see I'm just preceding these with a capital letter here, because that's the short name convention, and then the fields here I of course use lowercase. Now, again, if it's not going to not work if you don't have this, but you're going to be marshalling it off, you should be using this. And that's sequential. Oop, these are not the right type. Now, if the message, so now we've used out message, so we're going to message.message. Oh, yep, we need to replace this with our type. And then let's switch on message case. Now, this is where another thing comes in. So this is our messages. Now these are more, these are more constants, so we're gonna have to use. So all the messages actually start for WN. So we can search by WM. A bunch here. Let's just go to W. Paste earlier. Okay, so it's OXO. Now you can actually just copy this directly. This is the hexadecimal format. Some of the constants we use that actually I think most will. This is hexadecimal format. Now, like I said, again, wanted to private const. It's a uint. W hotkey. It actually this same thing. This is a little clear, so I'd usually recommend you that, although it doesn't matter a lot of the time. So this case WM hotkey, and then or we could see actually this WM hotkey. It's going to tell us what the WPARAM and the LPARAM mean, because these are basically things that can mean anything. These are basically the data that come with the. This is the data that comes. This is the data that comes with the message here. So the WPARAM. Where is the WPARAM? Where are you, bud? Okay, here it is. I'm blind. So the hotkey. So the identifier of the hotkey. So it's actually going to be like our ID, which I'm not going to be making the hotkey, but I'll just write in ID equals message.WPARAM. Now, our WPARAM, keep in mind, is a uint32. So I'm going to put 2int32. And I know it's not exactly the same, but that's how you're going to do it. So, convert it to video. But so, the next thing is the LPARAM. Now, this is going to be telling us the order word specifies the key that were to be pressed in combination with the key. So, the high order word to generate the wonder what the following values. The high order word specifies the virtual key code of the key. You can see this is actually split into two words. Now, this is where it gets a little weird because we're actually using our LPARAM to store two different things. The high order word and the low order word. So, the way we can get this, first we're going to search.per.264. I believe so, right? Double check this. Shoot. There. LPARAM. Trace this back. Where's the long pointer? Find it. No. Okay, here it is. In 64. Okay. We see in 64. That means it's going to be 64-bit, so it is actually a long set. That should be a long. Now, if it's Windows 64-bit, it's going to be a 64-bit thing. If it's not, it's going to be 32-bit, so we're just going to make it 64, and that should be fine. So, put the higher one, which is 64-bit, and to read the high and low order things, we need to actually use bit shifting. So, bit shifting. The high order, we're going to get the virtual key, right? The high order specifies virtual key code of the hotkey. So, okay, you can see high order word. You can put, what's a word? Well, word here. Find do it. Here it is. Sign short. U0 through 6535, and you can actually see, check that would sign out in 16-bit unsigned, so this is actually short, which is what I should write here. So, we're to get the higher and lower thing, which means we can actually make this an int, because there's no way it would be above that if it's just two words. So, depending on this, you can make it a long or 32-bit. We're just going to do this because that's all we need for now. See that 2 words adds up to 32 bits, means we don't need those extra 32, so we're just going to leave it like that. Now if we go back to WM hotkey, we can see the high order word. So how do we get the high order word? This is kind of weird, so we're going to do this. We're going to use bit shifting, basically means these two things. Now this looks like a greater than, but it's actually an operator to shift bits. Here's the reference for these. It'll refresh on this too, so this isn't for C#, this is for okay, I found this. You can see this has left shift and right shift, which is what I want. Now, or after this is not the same thing. What is this? Oh, okay, yeah, never mind. So you can see Y X shifted left 4 bits. Now, see, everything has shifted left 4 bits. This one, this one went 2, 3, 4. You can see it went 4 to the left. You can see another one here. 2, 4. These two went 1. Oh, we're gone. Another one did the same thing, and it just runs right off. You can see this. 2. So that's left shifting. That should hopefully make sense. So we shifted all left. 16 because this is 16 bits. Now it's going to return an int. Now we're going to just cast this to. We can either do this or we can keep it as an int. If we want it int. Keeping it as an int would actually probably be easy because there are more stuff that use ints, but if we want it as a ushort, you can do this. If you just want to use it like an int though, so just this, and this returns our high order. Now, for our lower order, which is our lower order. Dude, I think I closed the tab that I. And so that's how you get the higher order. Now, if you wanted the lower order, no, this is the max for an int. The last one works. So we have a bunch of 1s and 0s. That is our LPARAM. I didn't count those. That's just random ones at home. Then we're going to put our OXFF might be like this because there's actually some blanks here. This is the same number, it's just with the leading zeros, which even in hex make no difference. So these are all going to be 0 because this is AND. When these are both 1s, this one and this one are both 1s, that will make this a 1. So it's going to set all that to 0, and these are both 1s, these are not both 1s, these are both 1s, not both, both. You can see this basically erases everything now. So we have our leading zeros, these mean nothing. We're left. This thing we can see is smaller. Makes sense that it's our low order, then because it's the right side of it and it's the smaller part. Now our high order also makes sense that it is on that higher part. We want to shift it all, everything over so that we can get our high order. We can only have that. Should hopefully make sense. That is how we get the low and high words. Thank you. Oh, the last thing, probably. Can put like try. Or no, wait, no, that's not what you want. Yeah, so else, if it fails, we can see why did you fail. Wait, check this. Shell dot 32 right. It's an arrow code. Now it is only going to do this, however, if you have this here, which is why we did that, so we can check the error if we want to. Now this get message will always return true unless it fails for some reason. Now, even if there's not a message, it's still going to return true, and it's going to be blank, so that message that matches is going to be 0. But it's still going to return true, so keep in mind, usually when things are returnable in this, pretty much always they just return a bool, and the bool just signifies if it failed or if it did not fail. So that is how to Win32 API C#. Sorry for the bad audio. I had my settings screwed up. Also, forgot that what you need to call this is start message. This is the way you need to call it to make sure it doesn't bot the thread, like I said. Static and do start loop. But you're going to put this inside a threading dot system.threading thread without the parentheses there dot start there. And why is this not okay? Oh, it is okay. And there, you can see this will work. So thank you. Sorry for the bad audio for most of it, and that's how you do it. So thank you.